Hi students. Today I brought a new chapter from Chemistry class 11 part 1. So unit 3, the classification of elements and periodicity in properties. This video is part 1 of unit 3. Students, myself is Vedamurthy. You are watching my channel. Students, if you are not subscribed this channel, please subscribe this channel. And let us continue the chapter unit 3, the classification of elements and periodicity in properties. Students, this chapter is very important in chemistry class. In this unit we will study the historical development of the periodic table as it stands today and the modern periodic law. We will also learn how the periodic classification follows as a logical consequence of the electronic configuration of atoms. Finally, we shall examine some of the periodic trends in the physical and chemical properties of the elements. First, we should know why do we need to classify the elements? Because we know that the elements are the basic units of all the types of matter. During 1800 years, only there are 31 elements are known. At the 1865, the number which is identified is doubled more than 63. Today, at present, there are 114 elements are known. Of them, recently discovered elements are man-made. Efforts to synthesize the new elements are continuing till date. With such a large number of elements, it is very difficult to study individually the chemistry of all the elements and their innumerable immemorable compounds individually. To solve this problem, to make it easy to study the chemistry of the individual elements, scientists researched as a systematic way to organize their knowledge by classifying the elements. Not only that, it would rationalize the known chemical factors and elements about the elements, but even they predict new ones for undertaking further study. How the periodic classification is exist? So genesis of periodic classification. So classification of elements into groups and the development of periodic law and periodic table are the consequences of the systematizing the knowledge gained by a number of scientists through their observations and experiments. We'll study one by one scientists, what they made, what they are contributed to the periodic table. First we'll go to study about the German chemist Johann Debriner in early 1800s was the first to consider the ideas of trends among the properties of the elements. In 1829, he noted the similarity among the physical and chemical properties of the several groups of three elements, that is called triads. In each case, he noticed that the middle element of each of the triad had an atomic weight about halfway between the atomic weight of the other two. We can see in the table, this is one here. Look at the examples what's given. Element lithium, atomic weight is 7. Potassium having 39. So half of the 39 and 7 will get nearly around 20 or 23. So the sodium is 23. Sodium atomic weight is 23. Same way, calcium, strontium and beryllium, in between strontium having the atomic weight 88, which is the half of the calcium 40 and beryllium 137. Sorry, barium 137. And another one set of example, that is chlorine, bromine and iodine. See, chlorine having the atomic weight is 35.5 and the iodine having the atomic weight is 127. You can make it divide the 2 by 127 and 35.5, you'll get nearly around 70 to 80 plus. So the as per the Brinier triads, bromium is the having 80 atomic weight. Okay students, yes. Also the properties of the middle element were in between these of the other two elements, since Dobrynin relationship referred to as the law of triads seem to work only for a few elements. It was dismissed as a coincidence. This is worked for only few elements. That's what this law of triads or Dobrynin classification is dismissed. So next one more attempt was done by the French geologist A.E.D. John Cortais in 1862. He arranged known elements in the order of increasing atomic weights and made a cylindrical table if and made a cylindrical table of elements to display the periodic reoccurrence of the properties. So this also did not attract much attention about the classification of elements. So another one came English chemist John Alexander Newlands in 1865. He propounded the law of octaves. He arranged the elements in increasing order of their atomic weights and noted that every eighth element had properties similar to the first element that we can see in the table. This is one. This is as per Newland's octaves. See here, you can see this. Lithium atomic weight is 7. Beryllium is 9, boron is 9, 11, and carbon is 12, nitrogen is 14, oxygen is 16, fluorine is 19. It is in increasing order. Same and having the same properties. And the second one, element sodium having atomic number 23, magnesium 24, aluminium 27, silicon is 29, and phosphorus is 31, and sulfur is 32, and chlorine is 35.5, and potassium is 39, and calcium is 40. This is the increasing order with the similar properties. So the relationship was just like every 18th element that resembles the first in octaves of music. Newland's law of octaves seemed to true only the elements up to calcium. Although his idea was not widely accepted at the time. For his work later awarded Davy Medal in 1877 by the Royal Society of London. So the periodic law as we know today owes its development to the Russian chemist Dmitry Mendeleev 1834 and 1907 was worked, and the German chemist Lothar Meyer 1830 and 1895. So they were worked independently. Both the chemists in 1869 proposed that on arranging the elements in the increasing order of their atomic weights, similarities appearing in physical and chemical properties at regular intervals. So Lothar Meyer plotted the physical properties such as atomic volume, melting point, and boiling point. So atomic weights and obtained a periodicity repeated pattern. So unlike Newlands, Lothar Meyer observed a change in the length of that repeating pattern. By 1868, Lothar Meyer had developed a table of the elements that closely resembled the modern periodic table. However, his work was not published until after the work of the Dmitri Mendeleev, the scientist who is generally credited with the development of the modern periodic table. While Debrunier initiated the study of the periodic relationship, it was Mendeleev who was responsible for publishing the periodic law for the first time. So it states that the properties of the elements are a periodic function of their atomic weights. Mendeleev arranged a Mendeleev arranged elements in horizontal rows and vertical columns of a table in order of their increasing atomic weights in such a way that the element with similar properties occupied the same vertical column or group. So Mendeleev's system of classifying the elements was more elaborate than that of the lower Lothar Meyers. He fully recognized the significance of periodicity and used a broader range of physical and chemical properties to classify the elements. In particular, Mendeleev relied on the similarities of the empirical formula and properties of the compounds formed by the elements. He realized that some of the elements did not fit in with his scheme of classification if the order of atomic weight was strictly followed. And he ignored that the order of atomic weights, thinking that the atomic measurements might be incorrect, and placed the elements with the similar properties together. Say, for example, iodine with lower atomic weight than that of the tellurium. So that is, you can see tellurium. So the tellurium in the group 6, we can see this is in the group 6. So the tellurium is having 127.6 atomic weight, was placed in the group 7 along with chlorine, along with fluorine, chlorine, bromine, and iodine. Iodine having 126.5 is the atomic weight, which is less than the tellurium. So at the same time, keeping his primary aim of arranging the elements of similar properties in the same group, he proposed that some of the elements were still undiscovered and therefore left several gaps. So, in the periodic table, for example, both gallium and germanium were unknown at the time when Mendeleev was published the periodic table. He left the gap under aluminium and a gap under silicon. Okay. So those things he named as for where he kept the gap for aluminium in that place. He mentioned eco aluminium, that is for gallium, and eco silicon for germanium. So Mendeleev predicted not only the existence of gallium and germanium but also described some of their general physical properties. So these elements were discovered later, and some of the properties predicted by Mendeleev for these elements and those found experimentally are listed in the table that you can see here. So eco aluminium is predicted atomic weight is 68, and gallium, when it was determined, when it's found, so atomic weight is 70. Same way, eco silicon is predicted 72 is the atomic weight, and germanium, when it was um, found, so the atomic weight is 72.6. In the same way, density and melting point, formula of the oxide, formula of the chloride, all are very close to predicted as well as the found actuals. So you can see the density of the eco aluminum predicted is 5.9, and density of the gallium when it was found, it is having 5.94 density gram per centimeter cube. And eco silicon when it is predicted, it is 5.5, and germanium when we can come into existence, it shows 5.36 density. Same you can see the melting point. So eco aluminum was predicted at the low melting point, but they're not said what is the melting point of the exact. So when it is found, so gallium having 302.93 melting point per Kelvin, and for eco aluminum, silicon predicted high melting point, then germanium when it is found, it was 1231. Same formula of the oxide, so E2O3 as per Mendeleev's prediction, eco aluminum prediction, E2O3 when it is found, Ga2O3, and eco silicon is predicted as the formula of oxide as per Mendeleev's EO2, and germanium can name found GeO2. Same formula for the chloride, ECl3 was predicted by Mendeleev. So gallium when it is found, the formula of the chloride is gallium CaCl3, GaCl3, and gallium chloride. So when is predicted ACl4, the 4 molecules of chlorine, so it was found when germanium, so that formula of the chloride is GeCl4. So students, the boldness of the Mendeleev quantitative prediction and their experimental success made him and his predictive formulas as a famous and published in 1905, as this is the Mendeleev periodic table, and which was published in 1905. I hope students this chapter part 1 you understood. Thanks for watching the video.